always carry our lanyards, but we still need a separate phone stand. And when I need one for online meetings, I never have it. What if we combine both into one product? We come out with Lanyard phone stand. In this video, we will talk about our product development step by step.
Yay! Welcome to this explainer. Today, we're going to unpack the really fascinating step-by-step product development journey of a brand new hardware accessory, the Lanyard phone stand. I am so excited to guide you through this, because honestly, taking an idea from just a simple thought in your head all the way to a physical object you can hold in your hand, it's a complex but deeply rewarding process. So today, we're getting a front row seat to see exactly how that happens. Our roadmap today covers 6 steps: assessing the product concept, asking the target market, analyzing user needs, architecture and specifications, visualizing the CAD design, and finally, the 3D printed prototype. Let's dive right in. Step 1. Assessing the product concept. Okay, so every great product starts with a reality check, right? This wonderfully detailed SWOT analysis grounds our product in pure business reality. It shows us this isn't just a cool idea, it's a highly calculated venture. The goal here was to address a growing demand for multifunctional wireless solutions. The developers didn't just want to build a simple stand. No, they envisioned a powerhouse device offering charging, storage, and a stand literally all at once. They even tapped into opportunities like the huge rising trend of mobile gaming and video streaming, which absolutely required this exact kind of hands-free support. But here's where it gets really interesting. We have this striking contrast between those awesome intended features and the harsh practical realities of manufacturing. The standout strengths they listed, things like simultaneous charging for a phone and a smartwatch, an LED status indicator, and a built-in cooling system to stop your device from overheating, those are fantastic selling points, but they directly feed into the product's main weaknesses. Adding cooling fans and charging coils, that means higher production costs, a chunkier physical size compared to your standard charger, the absolute need for an external power source, and even a slight buzzing noise from that fan. It is just a classic engineering trade-off. Step 2. Asking the target market. To get the crucial data they needed, the creators launched a targeted Google Forms survey. They went straight to potential users and asked highly relatable questions to really understand their daily struggles. I mean, questions like, how often do you experience hand fatigue? Or how often do you deal with your phone slipping? Come on, we've all experienced that dreaded phone drop to the face while scrolling in bed. Asking this is exactly how you validate that the problem you're trying to solve is actually a problem real people care about. Step 3. Analyzing user needs. After locking in those crucial demographic parameters, things like daily phone usage hours and a preferred price point hovering right between 10 and 20 ringgit, they mapped out the solutions, and it perfectly illustrates how the specific pain points identified in that survey map directly to the proposed hardware. When respondents talked about watching videos, attending online classes, or traveling, it became super clear that struggling to do these things hands-free was a massive headache. Hand fatigue? Well, that means you need a stand. Dropping the phone all the time? That means you need a lanyard. The concept was brilliantly bridging these two user problems. The survey respondents also didn't hold back on what they wanted the final product to look and feel like. They quickly prioritized key physical attributes: an adjustable length for the lanyard, a really strong grip so the device doesn't slip out, a foldable stand for easy portability, and of course, it had to be lightweight, stylish, and made of durable material. This exact wish list, that became the strict marching orders for the engineering phase. Step 4. Architecture and specifications. Now we make the definitive shift from theory to actual engineering, with precise A3 technical drawings. We're looking at multi-angle orthographic views, top, front, side, and isometric perspectives. This right here is the universal language of hardware manufacturing. It provides the exact mathematical layout needed to understand how the folding mechanism operates, the precise thickness of the base, and exactly where that lanyard loop needs to sit. The absolute crucial takeaway here is the strict attention to detail required in hardware creation. These standard manufacturing callouts are all about quality assurance. It explicitly states all dimensions are in millimeters, standardizing everything for the fabricators. But even more importantly, for a product that you literally hold in your hands or wear around your neck, it mandates the manufacturer to deburr and break sharp edges for safety. Because, let's be real, nobody wants a convenient phone stand that ends up slicing up their hands. Step 5. Visualizing the CAD design. By rendering these models in 3D CAD software, we can clearly visualize the form factor way before a single piece of physical material is ever cut. We can perfectly see the top attachment loop on the back panel. That's a spot where the lanyard actually clips in. And we also get a great look at the front profile, which features a device holding lip at the bottom, engineered with a very specific depth to ensure a solid, strong grip on the phone. Exactly what the survey respondents were begging for. Doing this digital prototyping step is absolutely vital. It allows the designers to test how moving parts, specifically that tricky top folding hinge mechanism, will actually interact in real life. They can check for clearances, ensure the parts won't awkwardly collide when folded flat, and verify the structural integrity of the lanyard loop itself. Doing all of this digitally, it saves a ton of money by preventing you from wasting your production budget on flawed, useless physical molds.
Step 6. The 3D printed prototype.
At long last, we have the actual 3D printed prototype. This is that magical moment where theory finally meets physics. Having this physical model means the engineering team can hold the product and test the actual real-world friction of that top hinge. Is it too loose? Will the sheer weight of a smartphone just cause it to collapse? They can also rigorously check the stability of the bottom feet when the stand is placed on a flat desk.
If you get up close to the textured surface of this 3D print, it reveals the raw, messy, iterative nature of hardware development. You can literally see the layer lines from the plastic filament being extruded and a few rough edges hanging around the hinge pin. And you know what? That is perfectly normal at this stage. It's definitely not polished enough for retail shelves just yet, but it does exactly what it is supposed to do. It serves as a fully functional proof of concept that proves beyond a doubt that the folding geometry actually works.
And there it is, a tangible, physical realization of the initial concept. It survived the early SWOT analysis evaluating its multifunctional capabilities, it passed the market survey defining the need for a lightweight, foldable stand, and it made it through the brutal math of the technical drawings. Now it is standing ready on the desk, fully prepared to solve that dreaded daily hand fatigue and make online classes or video watching an absolute breeze. As we wrap up this explainer, I want to leave you with a thought to chew on. You have now seen the entire development pipeline. Knowing all the business constraints we discussed, the specific user demands for pricing and durability, and those intricate engineering specs required for the folding mechanism, what exact steps would you take next? How would you refine this rough 3D print to mass produce it affordably and sell this stand to the entire world? Thank you so much for joining me on this journey, and as always, keep analyzing the world around you.